So the downside to this is that I am writing on my iPad. The last time I did it, I was much better towards the end of the semester than I was at the beginning. Okay, so let's hope for that. Okay, that I will improve at writing with it. But there might be a little, issues. Sometimes there can be technical difficulties, but usually it's pretty smooth. So set theory is the first unit. It's a pretty easy unit. I'm not going to lie to you about it. It's probably one of the easiest units of the course. Not a bad way to start, I guess. However, it can be deceiving to people. They think the rest of the course is going to be this easy. It won't be. This is probably the easiest unit of the course. Okay, so units 2 and 3 are significantly harder. So please don't come, today and think, oh man, that's so easy, I don't have to come to that class, because that will probably lead to being back again next year. Okay, so it is a nice, simple unit, though. There's a lot of words in it, though. Like, if that's not a strong suit of yours, it can be a little bit tough for some people. A lot of vocabulary and stuff. As you can see, our objective today has a lot of vocabulary in it. There's a lot of really specific notation. So, really specific ways that you're expected to write things and expected to be able to read things. So that can be kind of hard. So there are like hard parts to it, or harder parts to it, but for the most part, it's pretty simple. So let's get going on it. What I'd suggest is to follow along and write down what I write in your notes so that you have them. That would be my suggestion to you. Okay, it's of course up to you. I can't make you do that. But that would be probably the best way to go. At the end, you'll have a nice set of notes that you can study off of and everything. Okay, so I leave blank spaces for you to write if you need to. And you can also, of course, write however you want in your book or however you want to do it. Okay, so we're just going to go over some examples here. This is a pretty straightforward example. This unit, parts of it won't feel very mathy. It's heavy on the logic. It's part of this course that there's only actually 3 overarching topics in this course. It's supposed to be logic, probability, and functions. Okay, so it's really only 3 parts. This is the logic part of it. So a lot of it won't feel very mathematical. There won't be a ton of numbers. Okay, but it still is math. Logic is a type of math. So here we use sets to help us organize things into categories. And we do that in our daily lives all the time, whether or not you realize it. It's like the set of animals. Like when you were very young, figured out all these different things are all animals. And then eventually, you probably figured out, okay, these things are amphibians, and these things are fish, and these things are birds. And those are all sets, and we use them to help us categorize and make sense of information. We need that. As humans, it's really important, and it's a really important part of our development, is being able to make more sets. So a set is a collection of distinguishable objects. So the word distinguishable, what does that mean? Yeah, you need to be able to differentiate them. That's exactly what it means. It means that they cannot be identical. Hello? Sure. Yeah. Reese, they want you in the interagency area. Schedule change. Mateo, you have a question? Yeah, sure. Okay, so distinguishable, it's also in front of you, but yeah, no, just, for my writing, that's good. Okay, so distinguishable means different, that you're able to tell them apart. That's really what it means, like what Jonathan said, spot on. So you can't have a set with a bunch of the same thing. And you can't be like, oh, this is a set of animals, and it's dog, 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 dog. That is just the word dog over and over again. That won't be enough. You could have, different types of dogs, but they have to be distinguishable. Hey, for instance, the set of whole numbers. If I was writing down the set of whole numbers, and number sets, you spend a unit in grade 10 learning about the different number sets, and that's a big part of, if we were looking at specifically math, number, set theory, that's a big part of it. So the whole numbers, if you weren't aware, and this should be a curly bracket. I'll try to draw it as nicely as possible. I'll draw it with marker too, so you can actually see it. 0, 1, 2, 3, 4, and it just keeps going, right? We keep going. Okay, so that's one of these. I think you can kind of tell, even with my writing, but it's one of these, right? If you have trouble with those curly brackets, it's okay, just try your best. Okay, I'm not grading you on it, but there should be some semblance of an effort to draw those. That's set notation. We use those curly brackets around the lists. Okay, so An element, this is the next definition, we got like lots of words here to know. An element is an object / number / word in a set. So for instance, in this set of whole numbers that I wrote up here, 0 is an element. Okay, that's an element. 1 is an element. 2 is an element, and so forth. The universal set is a set of all elements under consideration for a particular context. So that doesn't mean universal set is everything always. It's like in a particular context, it's everything. So if I was talking about our school and the people in it, the universal set would be all the students and teachers and staff. Right? Then there might be smaller sets, like our class would be a smaller set within our school. Okay? So this example that we're going to go through, we're going to do a whole bunch of different questions about, is something that is sort of assumed you know. There are a few things in this course that I found can be difficult for certain students, where there's an assumption that you have some base knowledge. So this is one of those examples where the assumption is that you know the provinces and territories and that you have some general knowledge about them. That can be hard for students who just moved here from another country, okay, for obvious reasons. So unfortunately, that's just the case. It's like later on in this course, there's the assumption that students are pretty familiar with the deck of cards. And if you're not, kind of hard. So I've had students who have to come in and actually learn stuff about decks of cards or whatever. But hopefully everyone's at least kind of familiar with this. So there is a map of Canada there with all the territories and provinces listed, if that is not something you happen to know. So here where it tells us to list the elements of the universal set of Canadian provinces and territories C. C for Canada, right? That's what it stands for. You don't have to pick a letter that makes sense, but usually you would. So C for all of Canada, and here you would literally just list all the provinces and territories. So you can get going on that, I'll do it too, but you can probably do it faster than me. So, and you can use like shorthand, like Yukon Territory, Northwest Territories, Nunavut, BC, Alberta, Saskatchewan, Manitoba, I don't even know what letters they use, MB maybe, O, N, Q, B, Newfoundland, PEI, Nova Scotia, and New Brunswick. There we go. Whoops. Okay, and you just list them all and close it. So it's all just a big list with those curly brackets around it. And that would be the universal set because it includes all the provinces and territories. Every single one of them is on our list unless I messed it up, but I tried my best, so hopefully. Okay? So you do the same on yours. So universal is everybody, okay? Or everything in our context. You noticed, even though it's universal, I'm not listing things, I'm not like listing other parts of the world. It's only the universal set of Canadian provinces and territories. It's pretty basic. Okay, so a subset is a set whose elements all belong to another set. So I gave an example earlier. Our class would be a subset of the school. Okay, because we are all in the school. Okay, so it's like everything inside the subset also has to be inside the bigger set. Okay, so it has to be in both. So if we're talking about the Canadian provinces and territories, there are some subsets that we talk about a lot. Does anyone think of a subset of all the Canadian provinces and territories that we might talk about?
Edmonton?
No, because we're looking at provinces and territories. So like think about like a group of provinces or territories that gets talked about. The prairies. Okay, prairies. So maybe we would make up like something like P for the prairies, and we might say, and this is subjective, like different people could have different thoughts of what prairies mean, but generally it probably looks something like Saskatchewan, Alberta, and Manitoba. That would probably be what most people would write. Okay, so what would be another example of a subset of provinces and territories? East Coast. What do we call them a lot of the time? Maritimes. Okay, that would be an example. Okay, the Maritimes. Okay, that would be an example. Territories would be an example. Provinces would be an example. Okay, so there's lots of possible examples that you could make up. It's any smaller set. So it's like I could even make up some set. Like I could just be like Central Canada. I guess that's not made up. People do talk about Central Canada. But we could say Central Canada, and by that I mean Ontario and Quebec, and that could be one. You know, like you can make up almost anything as long as it's all of them are part of our bigger list. Okay? So down below here, subset of Western provinces and territories, W. So we're just saying they made one up. They're making up a subset. They're saying Western provinces. And then they want us to say what W could be. And again, there's more than one right option here. Someone might say Manitoba and over is west. Someone else might say Saskatchewan and over is west. Someone else might even just say, well, it's just Alberta, BC, Yukon, Northwest Territories. Someone else could even just say, no, it's just Yukon and BC. It's just the most western, right? Like it's totally subjective. This is not something that there's a right or a wrong answer to. I mean, there are wrong answers, I guess. You couldn't be like, it's these ones. Okay, that would be wrong. But as long as you're naming Western provinces, pretty much are fine. So let's just pick, I'm just going to say Yukon, and maybe just do it the same way as me so that the rest of your answers are like mine. Yukon, Northwest Territories, Alberta, and BC. Okay? Just so that we are all on the same page kind of about it. Okay? So for provinces and territories, the four most western are the western provinces and territories. Okay? So one of the big things in this unit is Venn diagrams. We're going to be doing a bunch of them. They're super fun. I actually don't mind them. And they're used to organize information and kind of to draw this out. So if we were drawing this out, like for subsets, this is the important thing here that it's trying to get across, is for subsets. If I was drawing a Venn diagram, like if I made, you know Venn diagrams are those things with like the two circles, right? Like this, like that, and it's like, you know, the stuff in the middle is what they have in common. Hey, have you seen these before? Okay, so here, if I drew the subset, if I drew the set C, so if I was like, okay, well here's C, that's Canada. Where would I draw W? If where they intersect is what they have in common. So if I drew W, just to kind of explain what I'm thinking here, if I drew W like this, okay, that implies that there's something I could write here that is not in C. Okay? Like it's implying that part of W is outside of C. That's what it's implying, because there is, in my drawing, part of W is outside of C. Okay? That's not true, right? Like W, all the western provinces are completely inside Canada. All of them are. Okay? So this is a lie. Like if I was writing out my provinces and stuff, I'd put Yukon in here because it's in common. I'd put Northwest Territories. I'd put Alberta. I'd put BC, and then there'd be nothing to put in that outside piece. So I don't draw it like that. I don't put it with an outside piece. Oops. No, I have no choice, apparently. I'll erase it if I have an eraser. Okay? No, which I don't. Okay, I'm just going to erase it for now. I'm sure people are caught up. Okay, so the way we actually do it is we put C, okay, we put C there, and then we put W, like inside of it. Okay, W goes completely inside of it. That's what a subset looks like. Okay, subsets are completely inside the other diagram. So just to remind people that W is Alberta, Saskatchewan, Yukon, and Northwest Territories. Okay, so if I was actually, and a lot of the time with these diagrams, sometimes I'm going to make you write in the elements, like you're going to actually have to write down all the things, like you'd have to go in and write in, like, here's the Northwest Territories, here's Yukon, here's Alberta, here's BC, and then out here write down the other ones, like you'd have to write down like Saskatchewan, Nunavut, Ontario, and so forth. And you just keep going until you had them all listed. Sometimes I will make you do that, where you have to actually list them all. But a lot of the time you're not going to have to. You just have to draw the picture. But it has to be correct. Like if W is completely inside of C, you have to draw a W completely inside of C. You can't have part of it sticking out. Okay, so it's like, it's a little picky, I guess. There's some pickiness to it, but you'll get the hang of it. Okay, Venn diagram's bad. Okay, now, what would the set that is the opposite of W look like? So remember W, we just listed it. It was Yukon, Northwest Territories, British Columbia, and Alberta. If I was going to write the set opposite of that, they tell us to call it W with this apostrophe on it. In math, that apostrophe is often called prime. So we would call this W prime. Okay? So what would the opposite of W look like? What would be inside of it? Everything else, like all the Eastern, but even not just Eastern, right? The opposite, the way we're talking about it here, is everything that it's not. So like West and East are opposites in sort of our language, but when we're talking the opposite of this West, we're not just talking about like, well, if these 4 provinces are West, then these 4 are East. Okay, we're talking about everything that isn't West. Okay, like everything else. So W prime, which we're going to kind of go with call it the opposite, is everything else. So it's Nunavut, Saskatchewan, Manitoba, Ontario, Quebec, PI, Newfoundland, Nova Scotia, and New Brunswick. Okay, it's like everything else. And that is actually called the complement. Okay, that's a pretty important word right there. Complement. It means opposite a lot of the time, but sometimes I guess opposite can be kind of tricky to think about. It's everything else. Okay, so if I was talking about the set of the school again, and we were talking about our subset, like our class, the complement to our class would be all the other classes. Like it would be everyone in the school who isn't in this room. Okay, so that's complement. So if we are trying to draw this now, they want us to draw. Okay, they tell us there's subsets T, the territories, P, the provinces. Remember, we have W, which is Western territories and provinces, and we have C, which is Canada. And they want us to draw a diagram of all of this. Now, the first thing to know is a lot of the time in this unit, the universal set, like in this case Canada, we'll draw it as just a rectangle. It makes it a little bit easier to do the rest of your work. So if I draw a big rectangle and I call that C, like, okay, that's all of Canada. Now, all those other things, territories, provinces, Western provinces and territories, they are all inside of Canada. So all those circles are going to go inside of Canada. So I'll just draw W first, because we already kind of did W. So if I draw W, okay. Now, if I draw the territories, are the territories going to be inside of C, or are they just going to be intersecting with C? The territories. Are all the territories inside? It'll be inside. And what about with W? Is it going to be inside W? Why won't it be inside W? Because of Nunavut. Okay? That's what I want you guys to be thinking about. So remember, the Western W contains Yukon and Northwest Territories. So it contains 2 of the territories, but it does not contain Nunavut. So if I'm drawing T, the way I would draw it is I would draw it intersecting with W, but it has to have some space outside of W as well. And if I was trying to write the things in here, I would write Yukon and NT in that inside space together. And I would write Nunavut here. So Nunavut is just a territory. It's not a Western province or territory, okay, according to us, that we made up. Okay? Now, what about the provinces? How would the provinces go? Will they intersect with W? Yes. What will go inside that intersection? Those will go outside, those ones. The ones that'll go, like, I guess it's the language that we got to work on. Okay, so if we draw P, right, like it's going to intersect with W. It won't intersect with T, right? Provinces and territories, they don't touch each other. Like there's no place in Canada that's both a province and a territory. Actually, I guess you could maybe argue we are, considering the devolution, but we're still a territory for now. Okay, so if we draw it, P would be like, you know, there. And maybe even, you know what, it doesn't really matter the size. I don't want you to get too worried about that kind of stuff. Like, you can draw it whatever size. But, I mean, P is a lot bigger than the territories. Like, if you wanted more space, if we were actually trying to list everything, you might want to make it bigger. Okay, so you could list everything. But if you're listing everything, right, like inside the intersection usually means kind of this area right here. That's the intersection point. Okay? And inside there, you would put BC and Alberta. Okay, it's hard to read, sorry, but you know what I mean. And then out here, you'd put everything else. So you'd put like Saskatchewan, Manitoba, Ontario, Quebec, Newfoundland, PI, Nova Scotia, and New Brunswick. And they'd all go in there. And again, like I said, usually I won't make you write these unless I specifically tell you to list the elements. You don't have to. It's more just the drawing. So knowing, okay, my T has to share part of its space with W. My P has to also share part of its space with W, but it better not touch T. It's having that kind of stuff. And it can be a little confusing. Some people find it really easy. Some people find it harder. It just kind of depends on how your brain works, I guess. So it takes different people different amount of time. All right, does anyone have any questions about that diagram, though? And notice everything's in there. Like that's all the provinces and territories have been listed now. So there'd be nothing outside. But if there was, like, I don't know, if we were like the United States or something, like, you know, they have, like, Puerto Rico is not really a state, but it is a part of the United States. Like, they might have that listed, like, outside in this space out here. Okay? That's the area. Okay. Now, so that's kind of a weird question. Consider the set of Canadian provinces south of Mexico. M. They want us to call it M. Can anyone think of one? Ontario, maybe, no. Right? Mexico is way down south. So, there is none. The way we write that, if you have something where like this, where you're given a situation, like if I was like, name, like somebody in our school who goes to Citizens. It's like, no, nobody in our school goes to Citizens, right? Like it'd be, there's nobody to list. Okay? Mexico, south of Mexico, since there's nothing to list, you can either leave it just blank like this, or more commonly, you see something like this with a 0 with a line through it, or even without the brackets and just 0 with a line through it. Okay, they're all the same. They all mean there's nothing. So that there are no, it doesn't exist. There are no Canadian provinces or territories south of Mexico. This is called the empty set. Okay, so if I say the empty set, I mean like a set with nothing in it. Just, it's empty, blank. Okay, now, we're almost done this. I know there's a lot of vocabulary here. It's kind of painful a little bit at the beginning. Disjoint sets are two or more sets that have no elements in common. So it's two subsets, or two sets, can be any two sets, that have no elements in common. So, for instance, let me think of something like, if I was talking about grade 9s and grade 12s, those are two sets. There's no grade 9 student in the school who's also a grade 12 student. Okay, that just doesn't exist. Okay, or if I was talking about teachers and students, there's no teacher in the school who's also a student at the school. Okay, that's two things that would not touch each other. If I drew a Venn diagram for them, they would be not touching. They would be like completely separate. So what are examples of two sets of Canadian provinces that are disjoint, which means that they have nothing in common? Territories and provinces. That's an easy one. Okay, that's a good one. T and P. Okay, territories and provinces. There's not a single, like I just said earlier, there's no territory that's also a province. Okay, so if I drew them as Venn diagrams, they'd be completely separate. It would be T and P not touching each other. Hey, anyone? Any other ones? Any pair of type of province that wouldn't have any in common? You could just pick two and just have a single one. You could do that. You could say like Northwest Territories and Saskatchewan. Even though it's just one province, that's still a set. Even an empty set is a set. So a set of one is totally fine. It's something like Maritimes and Western, or Maritimes and Prairies, or Maritimes and Territories, or there's lots, right? You can make up however many you wanted. They'd going, but let's not, right? Let's stop there. Okay, so this is the notation, and I will be a little picky about it. Sets are defined using brackets. Okay, so you need to put the brackets in. If you don't, you'll be losing some points. Okay, if we're looking at the set, this is our universal set here, 1, 2, 3. Okay, sometimes you can just define it. Like I'm just defining a set there. I'm just saying that's the universal set. Well, that's everything we're looking at is 1, 2, 3. The set 1, 2, which I've named A, since 1 and 2 are both inside U, like they're both in here, that means A is a subset of U. And the way you write that is with this sideways U kind of thing. So the way I would draw that, if I was drawing a Venn diagram, is like I would have U, okay, that's U, and you can technically draw it whatever shape you want, but a lot of the time, like I said, the universal set, we put it as a rectangle, and then A would go completely inside of it. There's A, because 1 and 2 are inside, and 3 is out there. Okay, so it's completely inside of it. Now, when you have something that's completely inside of another set, the way that A is completely inside U, you write A is a subset of U, like that. Okay, that's how you write it. You could write it out as words, like A is a subset of U, or you just write it nice and shorthand, like that. So it's the one that's inside goes first. You're saying A is inside U. That's what you're kind of describing there. Okay, and like we said earlier, complement is everything that's not in A. This tends to be hard for people at first. What I would suggest doing is, like, if you have a pencil, and you should, right, because we're in school, is if you're asked to find, like, if you're given a picture and you're asked to find the complement of something, use your pencil to color it in. If I see A prime, that means color, oops, that's really messy. Okay, color everything but A. Okay, because that's what complement means. Complement means the opposite. It's everything except A. That's what A prime means. So if I'm looking here, where I have this drawing, I color everything except A. So I color all the outside from A. So in this case, the only thing that got colored was 3. Okay, 3 was the only thing out there. Okay? So you're coloring everything except whatever has a prime on it. Okay, so let's just do a quick example of that. Okay. So say I had, I don't know, let's make kind of one up that's a little more complicated. So if I have U, and I have A, and I have B, and let's just put some things out here. Let's say I have, like, I'll put some numbers, 3, 5, 6, 9, 10, 12, 14, 16, 18. Okay? So say I have this set here, and I asked you, what's B prime? Okay? The way I would do it, this is what I think is the easiest way, is B prime means everything that's not in B. So I'm just going to quickly shade in everything that's not B. Now what's important to notice here is that 9 is inside B. That's part of B. Because B is this whole circle. So that's the only part that doesn't get picked. So everything I shaded counts. So that's 3, and I'd use my bracket, 3, 5, 6, 14, 16, 18. Okay? Everything except B. That's what a complement is. Okay? And here I could say that A is a subset of U, and I could say that B is a subset of U. Okay? Because A and B are both inside of U. But I could not say that A is a subset of B. Hello? Hey. Sure. Okay. Okay, bye. Charlotte, if you still need your course changed, they're ready for you. Mr. Rad. Okay? So anyway, I couldn't say A is a subset of B because A is not inside B. Does that make sense? A and B, they're just touching. One's not inside of the other. Okay, so it's a little tricky at first. This takes practice. Let's do a few examples that are the kind of thing you're going to see. Okay, so here, and some of this stuff too, you might need to ask me for now, but some of these words you are expected to know. So if you see some of these words like multiples, for instance, you are supposed to know the multiples of 5 here. Okay, I'm actually not going to do set notation with you guys because I've looked and it's never shown up on the departmental and it's terrible. So we're not going to do set notation. But we will look at other ways. So you should still know what multiples means. So multiples, does anyone know? Okay, I'm going to do 5s and 10s. They want us to do both. So 5 and 10. So F for 5, T for 10. What would be the multiples of 5?
It's not on the board.
Oh. How come? That's weird. It's on mine. Yeah, I wonder.
There.
Okay. Now it's here. So that's good. Okay, so 5s and 10. F for 5, T for 10. Okay, what is the multiples of 5? Sorry? Those are the factors of 5. That is not a bad guess. Okay, so factors are numbers that divide into something. So 5, 1 divides into 5, 5 divides into 5. That's all the factors of 5. Multiples of 5 are actually the opposite of that. So they are things that 5 divides into. So what would be the first multiple of 5? 5. Then what? 10, that's right. Then 15. And so forth, and you just keep going. And it says from 1 to 500, so 500 would be the last one, right? Because 5 goes into 500. Okay, now 10, same thing, but it's tens now. So it's 10, 20, 30, all the way up to 500. And notice how I put the ellipse in there, the dot, dot, dot. That's going to be instead of set notation. If I at any point give you a question that has set notation in it, it was an accident. So, well, actually, it could say the word set notation, but it's just not going to be like this. So if they're asking you for multiples of something, don't worry about it. I promise it won't be on the test. Okay. Now, it wants us to list any subsets. So imagine if I was drawing this, like if I was drawing T and F, okay, how would I draw them? Would one of them be inside of the other? No, don't even think about other sets, although 10 would be, like T would go into even, like, right? Like all the 10s are even. But just think about these two. Like if I was just drawing the 10s and the 5s, how would those circles kind of work? Would one be inside of the other? T would be inside of F. That's true. Okay, so if I drew F, T would go inside of it. Because 10 is an F, 20 would be an F, 30 would be an F, 40 would be an F. Anything that is divisible by 10 is also divisible by 5. That is just true. Okay, that's something we know, hopefully. Okay, so the way I could write that then is that T is a subset of F. But I think what Ethan was saying to you is true. Like if we were looking at other sets as well, like if I look, all of the 10s, like all of these, they're always going to be even. So if I made up another set, if I said, and there's the even numbers, E, then T would also be inside of E. Okay, you can have, like, there's tons of different possibilities here. Okay, and then this is B already. I already did B here with my diagram. So I'm ahead of the curve. Okay, so I think with subsets, there's more than one way to think of it. You can just think, like I know 10, there's 10, And I know 20 would be in there, and I know 30 would be in there if I kept listing them and look at it that way. But trying to actually draw the Venn diagram is actually very useful, a way of seeing if something's a subset. Because it's a subset if you would draw it completely inside. So as long as you would draw it completely inside, it's a subset. Okay, that's just a pretty simple question, I think. Although the word multiple would probably throw people. I assume if I gave that on a test, like 3/4 of the class would get it wrong just because they wouldn't know what a multiple was. So that's a word I'm telling you you need to know. You need to know the word multiple. So if it's multiples of 3, that means 3, 6, 9, 12, whatever. You should also know the word factor, like what Kateri suggested, which is a great guess because it had to be one or the other. Okay, factor is the opposite of that. So like the factors of 10 are 1, 2, 5, 10, because those numbers go into 10. Okay, so that's another word that you are expecting. Okay, just 2 more quick ones. We'll get through it. Alden and Connie rescue homeless animals and advertise in the local newspaper to find homes for the animals. They are setting up a web page to help them advertise animals. These are the kind of questions you're going to see, by the way. Like, they're pretty easy. And there's not always a wrong or right answer, so it's nice. It's a little subjective. Okay, they currently have dogs, cats, rabbits, ferrets, parrots, lovebirds, macaws, iguanas, and snakes. And if I give you an example where you don't know what some of the stuff is, please just ask me. Okay, it's not a big deal. We do one with sports later on, and there's often lots of people who don't know a lot of the sports. Okay, so it's not a big deal. A, design a way to organize the animals. Represent your organization using a Venn diagram. So if you were making a website here, and you wanted to kind of organize this, you probably wouldn't have all these individual things listed. What groups might you group these animals into? Birds, mammals, and what?
Avians and reptiles.
Yeah, reptiles, let's just say. Let's just go with reptiles. I don't know if... Okay, let's just go with reptiles and say it, that they're part of it. So if I was going to draw these in a Venn diagram, right? These 3 things are completely separate, right? They wouldn't touch each other. Okay? So if you were drawing this, and again, there's more than one right way. You could have done something else. You could have been like, I don't know, I've had people suggest things like, oh, like 4 legs and 2 legs, or, you know, you could do different, whatever. You could do this however you wanted. There's more than one right answer. But if I was doing it this way, it would be pretty easy because they'd all be disjoint. Like, and this is important too, that you don't, technical difficulties. It's like the end of the day. It's tired.
We'll call it quits.
Yeah, and that's it. Okay, but we have birds right here. Okay, mammals and reptiles. And we would say that these things are all disjoint. There's no subsets, except that like all mammals are also animals, and all birds are also animals. And if you wanted to call that a subset, I guess you could. But most people probably wouldn't. Okay, so they're really just 3 separate things, and there's no crossover. Okay, so C there, question C is, B wants you to name the disjoint sets. You would just say B, M, and R are all disjoint. There's no subsets here. Alden said that the set of fur-bearing animals could form a set. Another set that would be equal to that is one we have already, right? Mammals. Okay, so for question C, mammals is the same as fur-bearing. They'd be equal. So 2 different people might have come up with different names, but they're still equal sets. That's all it's trying to say. Let's do one last thing here. This is a good one to do because it's a little bit different. And then we'll be done. Okay, we'll do some practice. Biljana recorded the possible sums that can occur when you roll 2 4-sided dice. Okay, so you're actually going to have to draw these outcome tables a lot in the next couple of units, so it's kind of good to see them. This is like, imagine she rolls 1, and they even made it blue and red. So imagine she rolled 1 blue dice and 1 red die, and then the sums are in the middle. So if she rolled a 1 and a 1, that's 2, right? You add them up. That's how you roll dice. I'm sure you've all done it before. Okay, if you roll a 1 and a 2, you have 3. If you have a 2 and a 2, you have 4, and so forth. So those are all the possibilities. The highest she can roll is 8. Okay, because if she rolls 2 4s, she gets an 8. Now they say, display the following sets in one Venn diagram. Rolls that produce a sum less than 5, and rolls that produce a sum greater than 5. Record the elements, number of elements in each set. Okay, so this is a thing here. So we have to name them. So I'm going to call it L for less than 5 and G for greater than 5. Okay, now if I'm rolling this here, okay, less and greater. Now why don't I have them touching each other? Why don't I have them overlapping?
You can get less and greater.
Yeah, you can't do both at the same time. There's no number that's going to be both less and greater.
What if you get 5?
Now, if you get 5 exactly, that's a really good question. That would go outside of both of them. So there are some rolls that give you exactly 5, right? There's, how many different ways could I roll exactly 5? 4. So one thing I can put out here is outside of both L and G, I could put 4. That means that there's 4 ways to roll exactly 5. Okay, that's why that's there, because there's 4 ways to roll 5. Okay, now how many ways are there to roll less than 5? 14? No way. Less than 5. 6. So you could put 6 here, and G is also 6. There's 14, no, there's 16 things in total. But there's 4, or 6, sorry. There's these, and these, that's 6 for the less. Okay? So those are the oh, I see, you counted the outside part? Yeah. Okay. So that is writing down the number of elements in each set. So I'm saying there's 6 different ways to roll less, 6 ways to roll greater, and 4 ways to roll exactly 5, which is neither less nor greater. Now, one more notation thing before I'm done, and then I'm all finished here, is when I'm writing down number of elements, the notation for that is like this. If I wanted to write, because if I wrote L equals, right, like L equals, I'd have to write one of those lists out. Like I'd have to write down all these things in there. So instead of that, if I want to write just that there's 6 of them, I write N, and in brackets, I put L, like that. That means number of elements in L, and that is 6. And that the number of elements in G is 6. Okay, so that's how you write that. That's a little, just a little additional thing. It's important to know, though. We'll be using it a lot. Okay, I'm going to hand out a worksheet here that's practice at exactly this. I will be around to help, so don't panic if you're finding it hard. And try to remember, too, that there, for some of this stuff there really is a right or wrong, but a lot of it there isn't. So, parts of it are subjective. If you have a slightly different answer than somebody else, don't panic. You shouldn't have your phones out. What? I'm probably going to run out of these. Actually, maybe not. Maybe I'm just because we've been having additional. Okay, I want everyone to finish this and hand it in. You may. Okay, perfect. AJ, give me your phone.
I want to wash my dog.